Okay, so good evening, everyone. So today we're actually going to be looking at, in the last class we talked about fragments, okay? So today we'll be looking at another concept, okay? We're going to be looking at view models. Today's class we'll look at view models, so try as much as possible to see how much we can finish this up today, but if we can't, then we have about just 40 minutes or so to round this up, 35 minutes plus. So maybe we'll just fix another class at another time and then finish up this. Okay, so you can actually, do your task that will be dropped tomorrow. Okay, so we're going to be talking about view models today. Okay, and then like I informed you, we're going to be building an application. It's more like a word application where words are scrambled. They get to choose, decipher the actual word. Okay, get to decipher the actual word. So let me just show you, let's just say demo of the application. Where are you? Okay, yeah, this is it. So this is it actually, this is the application. So you have a word that's going to be scrambled. So you get to unscramble the word using the letters. Okay, so this is I'll walk you through the project right now. I had to just set it up, of course. So there are 10 words per game. You can see 0 out of 10. Okay, and then you have a score. Now, so the problem now with this, okay, the problem with this code, okay, is, of course, you actually, now watch this. I won't put anything, I won't enter any word, but I'll click on submit. You can see, even when I don't even type in anything, I click on submit, it actually submits. You see 1 out of this and gives me a score, even when I do not put in anything. So you can see the app does not even check the word that's being entered. Okay, so the player, if I click again, you see the player is always scoring points. Okay, and then the number of words is increasing. So that's a problem. And then if I go past 10, it still gets to 11. So there's no way to actually even end the game. Okay, there's no way to end the game. Now another thing is, let's see, okay, let's take this back. I wanted to show you something, but let me first of all set this to rotate. Yeah, so I want to try to rotate this. Okay, so you notice when I rotate the application, I lose the score, I lose the number of words. It's like I'm actually just starting again just by rotating the application. So we're going to change that. We're going to fix. That's the right thing we're going to actually fix. Okay, so let me take this back. Okay, yeah, good. So these are the major issues with the application. Okay, these are the major issues we have. Okay, there's no way to save and restore the application state when you change configuration, which is the last one I actually just showed you. So of course we're going to save that using the on-save instance state. We're going to actually use that. So we'll talk about bundles and the likes. Okay, we talked about it in the last class, but let's see, we'll get to actually use that so we can store the values. Okay, so let me just give you a walkthrough of the code. So first of all, we have, let's go through the XML. We have the game fragment XML. Okay, so this is a fragment that has the design for the game. Okay, that's just it here. So you have the submit and this. You have 2 buttons here. Then you have a text input layout. Okay, so this is a better version of the edit text that you actually make use of. Okay, a better version of the edit text that you make use of. So this is from the material, following material design. And then of course we have the main activity XML. So this is just a fragment container. So it's actually housing our fragment. Okay, so we have an activity and then we have a fragment inside. We talked about fragments in the last class, and of course, well, we have the colors. So I have a dimension file here. So this holds every dimension that I'm going to be using. Okay, 16 dp, whatever dp that I'm going to be using. So I'm extracting that. So just like we extract string resource, we can also extract dimension resource. Okay. So then the main activity, okay, we don't have anything here, it's just a setup. There's nothing. The only thing we have here is that we're setting the content view just like we'd actually do on a normal day. So let me open this package. Okay, so I created a package here, and then we have this list of words. So here we just have a list of all the words that we have for the game. Okay, these are all the words we have. This is just a very long list actually, so you can have a random stuff. Okay, and then so we already have a maximum number of words, which is 10, and then we want the score to increase by 20. So you can actually play around with this. You can decide the score to increase by 10 as you actually want. Okay, so it's up to you. Okay, and then so in the game fragment, that's where we have some, important stuff. Okay, so there are some comments for you. Okay, I'll actually push this so you can, when you get the code, you can actually understand a few of these things from the comments. Okay, but let me just explain a few things. So we have variables, we have defined variables for the current scrambled word. Okay, because we need to know the particular word that is actually being displayed, the current scrambled word. Okay, so we just gave it test first. Okay, we also have the word count. We set it to 0 at first, and then we have the score. So these are the variables we have actually just defined. Then, of course, we have our binding instance, okay, which you already know about, to access our game fragments.xml. Okay, and here we're calling it binding. Then, of course, so we'll create our view model and the like. So, well, you actually know about all this. And then you know about the onView created. So in the onView created, that's where we are. We have our click listener on the submit button, and then we have a function to submit the word. We have a function to skip the word, and then we have the function to update the next word on the screen. So to submit the word, okay, what we basically do, we check the user's word and then we'll update the score. So it will take the scrambled word first, okay, and then we'll store whatever this function to get the next scrambled word. Okay, whatever, when we get that scrambled word, we'll store it as the current scrambled word. So this is the function. So what does it do? To get the next scrambled word, we take the all words list, okay, which is from our list of words here. We take this, and then what we do, we randomize it. We get a random item there, and we'll convert it to a character array. Okay, we'll store it in a variable called temporary word, and then we'll shuffle that, and then we'll return that word now as a string. So we'll cast it, return it as a string. So this get next scrambled word is just going to go to our array list and just get a word there. So it's now going to update it. It will now store it on the current scrambled word variable that we have. Okay, and then we have the current word count. So when you submit a word, it should increase the word count. So this is our word count here. It will increase the word count, okay, plus times by 1. Then the score also will update. Will update the score. Now the word count here, so this is just to set the text. Okay, this is just to set the text to get the current word count and the maximum. So that's just for this one. This is just to set this text to update it. And of course, to update the score also, we just use a string template, get string, and then we'll pass in the score. That's all. Then we have setup error text field, which is false. Okay. That's basically what we just have here. Okay, so we have the unskip word. Okay, basically what is being done here is just to skip. It was a function to help skip the current word. So in case you see a word you can't tell, you can't scramble it, so you can skip it. Okay, but skipping it, the word count should also increase. The word text is but the score should not. The score shouldn't actually increase when you skip a word. But if you notice, when we skip, okay, so you see the score is not increasing, but the word count is actually increasing. So that's actually fine. Of course, we talked about the get next and the get next scrambled word. Now we'll get to use these functions, restart game and exit game. So we'll talk about this. Now this is just an error text field. Okay, this to set and return the text field when you actually so you can see it if there's error. We'll enable there's a function called is error enable to set that to true. So we'll actually see this, and then we have the update next word on screen. So these are the four helper functions we have. This one just displays the new scrambled word. That's just what it is. Updates the next word on the screen. It just displays the new scrambled word. Okay, so that's just an overview of what we have here. So let's get straight to it now. To be able to implement this, we're going to learn about the app architecture. Okay, we're going to learn about the app architecture. Now, architecture basically provides you with guidelines to help you allocate responsibilities in your application. Okay, it's just about guidelines to help you allocate responsibilities in your application between classes. Okay, between the classes. Now, a well-designed app architecture will help you to scale your app and extend it with additional features in the future. Okay, so you know the literal meaning of architecture. Okay, so think of it as a building plan. Okay, guidelines as to how to build your house. So if you have a very good architecture, you can have a building plan that you can even expand. It may start out as probably a self-contained, but you can have such an architecture that it's possible to even expand it into a two-story, into a two-bedroom or whatever. Okay, so architecture provides you with guidelines. Okay, very important. So take note of that. And of course, it makes team collaboration easier. You get to understand this when we get to the project phase. So there are two most common architectural principles that we're going to be talking about. Two most common architectural principles that we'll talk about. Now, the first one is what we call separation of concerns. Yeah, so this is the very first one. Now, separation of concern, this principle actually just states that the application should be divided into classes. Okay, your application should be divided into what? Classes, each with separate responsibilities. Okay, so your app should be divided into what? Classes. Divide them into classes, and each of them should have what? Separate what? Responsibilities. That's one architectural what? Principle. Okay, one most common architectural what? Principle. Okay, separation of what? Concerns. Now, the next one is what we call drive your UI from a model. Driving UI from a model. Okay, so what does this actually mean? Okay, now, first of all, what's a model? Models are just components. Okay, models are components that are responsible for handling the data for your application. Okay, they are models, they are components that are responsible for handling the data for your application. Okay, so they are independent from the views. They are independent from the views and your and the app components in your application. They are independent of it. And this, because they are independent, they are not affected by your application's life cycle and whatever associated concerns, because they are what? Driven, they are independent from views rather. Okay, they are independent. They don't have any, they don't depend on a view to function. Okay, they are just what? Components. They are the ones who are responsible for handling what? The data. So they don't have anything to do with your views. Like, they don't depend on your views to do what they should actually do. And that's why the app lifecycle does not affect them. So this is one very common architectural principle: driving your UI, your user interaction, how the user interacts. You drive it from a model and not from the view. Okay, now the main components in Android architecture, okay, are your UI controllers. And when I talk about UI controller, I talk about your activity or your fragments. Those are UI controllers. Okay, so your UI controller, your view model, your live data, and room. We're going to talk about live data in the next, I think, yeah, just after view model. We'll talk about live data. maybe we'll look into shared view model first, and then we'll talk about live data and then room. So these are there are components in the Android architecture: UI controller, view model, live data, and room. Now, so these components, they take care of some of the complexities of our life cycle. Okay, and they actually help you to avoid life cycle related issues. Okay, now let me take it back a bit. Now, when I talk about your UI controller, I said activity and fragments, right? So what it does, your UI controller displays data and capture user events. Okay, let me just put this here. So your UI controller so it displays data, okay, and capture user events. That's why you have the activity and fragments that are UI controllers, okay. Now the view model, okay. Now the view model, which we're actually going to be looking into, it holds all the data that is needed for the UI and prepares it for display. Okay, it holds all the data for okay, let me spell this well. Sorry about that. So it holds for this UI controller to display, and it prepares it. It doesn't just hold it, it prepares it for display. Okay, it prepares it for display. So let's stay on them. Let's stay on them a bit. Let me still take that again so we can be clear. Now, your UI controllers, okay, they control the UI by drawing views on the screen, okay, capturing user events and anything that is related to the UI that the user interacts with, okay, that's handled by the UI controller. So data in your application or any decision-making logic about that data should not be in the UI controller classes. So just like we have game fragment, main activity, okay, where we had letter list fragment. Though, as far as a fragment, it's a UI control. It's a UI controller. Okay, so we are saying that the data in your application or any decision-making logic about that data should not be in the UI controller classes. Now, the Android system can destroy UI controllers. It can destroy fragments. We have on destroy. Can destroy activities at any time, depending on the user interaction, probably when it minimizes or closes it, or probably there's low memory. Now, so because these events they are not under your control, you can't actually really control it. That's why you should not store any app data or state in UI controllers. Instead, the logic, decision-making logic about your data should be added in your view model. Okay, so let's continue from where we stopped. So like I said, apologies for the disruption in the last class. So just a brief recap, and then we'll move forward with what we have to do. Okay, so we're talking about view model, and then we actually learned about the app architecture, okay, of which we said the architecture, helps you, it helps provides you with the guidelines to help you allocate responsibilities in your application between classes. Okay, we talked about the most common architectural principles being the separation of concerns, okay, like you can actually see, and then also driving UI from what a model. So in separation of concerns, we said that this principle, it just has to do with the app, that you should divide the application into classes. Okay, divide your application into classes, each with separate responsibilities. Okay, and then we talked about driving your UI from a model. Okay, we talked about the fact that models are just components, okay, that are responsible for handling the data for an application. Okay, and they are independent from your views and app components. So they are not, a model is not affected by an application's life cycle or any other associated concern. So we said UI should be driven from what a model. And we said UI controllers are basically what activities, your activity, your fragments. Okay, that's what basically the UI controller what is. Activity, what fragments. They are called UI controllers, and they control the UI by just drawing views on the screen, capturing user events, okay, and etc. So the data in your application or any decision-making logic about that data should not be in the UI controller classes, like we talked about in the in the last class before we had the network glitch. Okay, so we talked about the previous app we worked on. Okay, and then we talked about the one we are going to be working on, how we should have the logic of calculating the score, the word counts, and those should actually be what's in the view model, should not be in your fragments. Else they're going to be affected by lifecycle events. Okay, and then so we now talked about the view model, and we said the view model is a model of the application data that's displayed in the views. And of course, we said models are just components. Their job is just to handle data for an application. Okay, so the view model stores the app related data that is not destroyed when activity, or fragment is actually destroyed and recreated. So the data is still what's intact. Okay, the data is still intact. The view model objects, they are automatically retained. Okay, whenever your activity shows, I remember I've talked about activity lifecycle and the fragment lifecycle. Okay, so we're going to just be implementing view model right now. Okay, and to implement it, basically we'll just extend the view model class. The view model class is from the architecture components library. Okay, which already is inbuilt. Okay, so that's actually what that. So we're going to add a view model to our application right now. So let me just clear this up. So our view model that we're going to be adding, okay, that's where we'll get to store our application data. And our application data here, okay, from our game fragment, our application data here is going to be the scrambled word, okay, the scrambled word, the word count, okay, the scrambled word, the word count, and then the score, okay, that application data. So those are the things we're going to store in our view model. So this is the architecture. This is how it's going to be. We're going to have the main activity. Okay, the main activity contains the game fragments. Okay, remember I talked about fragments and how they are a reusable piece of UI. So they are also they are housed in the activity. So the main activity, then you have the fragment under it. So the fragment is what it's contained in the main activity. Okay, so this is going to be like this. The main activity is going to contain the game fragment, and then the game fragment will access information about the game from the game view model. The main activity contains the game fragment, and the game fragment will access, it's a fragment, so it's a UI controller. So it will access the information about the game from the view model. Okay, so let's actually do this. I don't know if I set that up already. Let me just check. Okay, so I've actually just set up the dependencies for the view model. You can actually see that here. This is for view model. I actually just set up for live data. We're going to be talking about live data. So I just actually put this up so we don't have to wait during the live sessions for it to load and the likes. Okay, so let's actually go. So it's very, very key you use the latest version of the library. Okay, how do you know if you're not using the latest version? I'll show you. You can see this. Okay, well, as far as you're seeing this, it means that there's a better version of it. So let me show you. So you can see a much newer version is the 2.4.1. The much newer version here is the 1.4.1. You can see, so it's actually advisable to use the latest version of the library. So okay, I hope this doesn't take a lot of time, but let's just do for just these two. Yeah, let's just do for these two. So I'll update all this while before our next class, especially the live data, where we'll talk about live data. Okay, so let's create a class for our view model. Okay, that's the next thing we're going to do. Let's create a class for our view model. So I'm going to just do something. So let's just do it in this package. So I'll just right click, new Kotlin class. So call it game view model. Okay. So okay. So okay. So remember we said that to use it, it has to extend the view model what class. Okay, it has to extend the view model what class. So to extend the view model class, just gonna add a colon here, and then I'm going to say view model. Okay, and then add my braces. Okay, so that is actually what that. Okay, so now we're not going to put any logic here, but what we've done, we've just created the game view model what class. Okay, so this is where the game fragment is going to access data from here. Now, so let's attach. How do we attach this view model to the fragment? Okay, how do you attach it to the fragment? So to actually associate a view model to a UI controller, be it an activity or a fragment, all you have to do is to create a reference. When I say reference, I mean object or instance. Create a reference to the view model inside that UI controller. Okay, so what I mean is, so now we want to, attach it to the fragment, which is the game fragment. So all I'm just going to do is this. So let's do this. So I'm going to just add a property here. I'm going to say private val. Okay, so let me say view model. Okay, and then of type. Okay, we have to specify what type it is. Okay, so it's of type game view model, which is the class. Okay, game view model, which is the class. Then I'm going to add something and say by view models. I'll explain what that means. Okay. Okay, so basically what I've just done, I've initialized. Remember, you can't actually just leave it this way. This is declaration. Okay, this is you declaring that there's an instance, but you have to initialize. Okay, you have to what? Initialize it. You can see property must be initialized. So I'm initializing this now by using this by view models. So this by view, this is what we call a Kotlin property delegates. Okay, I'll talk more about it. Okay, so but I'm initializing this game view model using by view models. Okay, by view models. Okay, and this is a Kotlin property what delegates. So now, what is this about? So basically, in Kotlin, each mutable var property. Okay, I talk about var. Okay, variable. Okay, but var, val is immutable. Now, each mutable val property has a default getter and setter functions automatically generated for it. Okay, to probably get a value or set a value. That's what we call getters and setters. Okay, so each mutable variable property has default getters and setters. Okay, now the setter and the getter functions, they are called when you assign a value or you read from the value. So when you want to get, you're reading from the value. When you want to set, you are assigning a value. But for a read-only property, which is a val, there's a slight difference. Okay, now only the getter function is generated by default in a val to get the value. Okay, the getter function is called when you read the value of a read-only property. So just because it's a val, you cannot update it, you can't change it. So by default, what is generated is a getter function for you to get the value. But a var, which is a mutable property, the getter and setter, because you can do both of them, those functions are generated automatically. So property delegation, remember I said by view models is a property delegate. Now, property delegation in Kotlin, okay, what it does is that it helps you to hand off the getter setter responsibility to a different class. So you just push that responsibility to get and set stuff. You just push that responsibility to a different class. So this class now is called the delegate class. That means the class you're going to push that responsibility to is called the delegate class. Delegate, okay? And that's what provides getter and setter functions of the property, and it will even handle its changes, whatever. So you're basically just taking that responsibility. Okay, I want this class to handle this particular property for me. Okay, so how do you this is just not it, but not the only thing. Now, how do you define, you know, a delegate property? How can you define it? So if you want to define a delegate property, you're basically just using the by clause, and then the delegate class is that. So what do I mean? Let me just do a colon here. Let's say var, you give the property name, what name you want to have. In this case, ours is Viewmodel. The next thing is that you give the property type. You give the property type, okay, and then you add the keyword, the by, the clause, the by clause. So by, and then you give the delegate class instance, which, so the delegate class are basically the class you're handing off that responsibility of getting and setting to. So by, you now pass the delegate class. So this is basically how how a delegate property is defined, okay, using the by clause. So in our application now, okay, if we initialize the view model using like if you want to just initialize it using the normal the default game view model constructor, of course this is what you have. If you want to initialize it, you have something like this, just like how you've been initializing your class. So say private val, let me say mView model. Okay, if I wanted to initialize it, okay, using the default game view model class, this is what I would have actually done, which is what most of you, of course, have talked about. This is how I would have actually done it. Okay, but the thing is this: doing it this way, the app will lose the state of the view model reference when your device goes through, let's say, configuration change. Your application, it will lose the state of this view model reference, this object you've created, okay, this reference, it will lose the state of that reference when the device goes through a configuration change. Now, for example, that if you rotate the device, your activity is actually destroyed and created again when you rotate your device. That means you now have a new view model instance with the initial state again presented to you. That's what that just means. Okay, so instead, we use this property delegate approach, okay, and then delegate the responsibility of the view model reference object to a separate class called the view models, which is this by view models here. Okay, so this means that when you access the view model object, it is handled internally by this delegate class, this view models class. And then this delegate class, it creates the view model object for you on the first access, and it will retain its value through configuration changes. And it just return the value when requested. It retains the value. So that's why we actually make use of the property delegate approach. So here, configuration change, you will lose this instance. You will lose it. But here, you don't get to lose it, okay? You don't get to lose it. So that's actually that. So let me just take this out of here. So now, let's now move our data to the view model, because remember, I want to drive the UI. Okay, I want to drive the UI from the model. So let's move the data to the view model, because separating your application's UI data from the UI controller, which could be your activity or fragment, it helps you, it lets you better follow, you know, the single responsibility principle, you know, whereby things just let this class just handle this responsibility. Let not one class not handle everything. Okay, so your activities and fragments, they're responsible for drawing views and drawing data to the screen. But your view model should be responsible for holding and processing all the data for your UI. So what we're going to do, we're going to move the data variables from our game fragments to the game view model class. Okay, so here that I have this private score, this, the current word count, and then this. Okay, I'm just going to move it. I'll cut it and take it down here. Okay. Now, of course, we have errors here. We have errors here. These are places that we have called it. Okay. Now, but the reason that we are still having these errors now, if you check here, this is private also. This is private, so you can't access it because this is a private variable. So you can't access it from here. Okay, it's a private variable. So now let's actually do that. We'll fix that. Because to resolve it, we can't just say, like, I can't just come here and say, okay, fine, because it's private, okay, let me make it public. Okay, so if I make it public, maybe that'll solve the problem. Well, of course, in Kotlin, you don't have to explicitly put public. It's redundant. If there is no accessibility modifier, it's public by default. So we can actually do this. It won't really work. Okay. Now the thing is, why you can't actually even do that, because your data should not be editable by other classes. Okay, your data should not be editable by other classes. No, it should not. Okay, because it's very risky. Because an outside class could change the data in ways that you don't even expect, that don't even follow the rules. Okay, for example, an outside class can actually change score to a negative value. It's very possible. So try as much as possible to make sure that data should not be editable by other classes. So inside the view model, the data should be editable. So they should be private and they should be var, VAR. But from outside the view model, data should be readable, but not editable. So that means the data that is exposed, the data should be exposed as public, but at the same time as val, VAL. Inside the view model, it should be private and editable, mutable, meaning it should be a VAR, a var variable. But outside the view model, okay, it should be readable, but not editable, meaning it should be public and val, VAL. So to actually achieve this now, we're going to use a feature called a backing property. Kotlin has a feature called backing property. Now the backing property allows you to return something from a getter other than the exact object. So you're not returning the object, you're just getting something from that object. So you have, of course, we have talked about for every property, Kotlin generates getters and setters. Okay, so for getter and setter methods, you could actually override one or both of these methods and put your own custom behavior. Override this, and then do what you actually want. So to implement a backing property, because we want to return something from a getter. Okay, we want to return something from a getter. So to implement it, we'll override the getter method so that we can return a read-only version of our data. So let me give you an example of a backing property. Now here we have let me just do something like this. Let's just consider something like this. So assuming I have a okay, so let's do this. Let's do this here. Let me see. Let's see. Where do I? Okay. Okay. Okay, sorry about that. Yeah, too. Okay, so let's do something. Let's create a count variable. Okay. Now I want to first of all set it to 0. Okay, so I'm declaring a private mutable variable. that can only be modified within this class. So it's private, is a var, we can modify it. Now I can declare another public immutable variable that will override its getter method. It will return the private properties value in the getter method. And then when count is assessed, the get function is actually what called, and then the value of that this is returned. So what do I mean? I can now create a public, of course I didn't put private there, so by default it's public, but count, and I want to say this is of type int, right? A public immutable, that is val. Now I want it to override, I want to now override its getter method. So I'll now say get, can see this getter method. So what do I want it to get? I want it to get the what, the value that we have in the underscore count, and then I'll do this. So I can now have access to this one, but I am just reading it. I can't change it from the outside. So because this is public, any class can, can actually just get access to this guy because it is public, but it is a val, so it cannot be modified. But inside of the view model, the game view model, I can play around and update this anyhow I want. Okay. So that's basically what that's. Okay, that's basically. I don't know if you have any questions. Of course, just you can actually just raise your hand or just say it. So inside here, like I said, the property, this is private and mutable. So it is only accessible and editable here within this view model. Okay. So but outside the class, outside it is what? Public. Okay, count here now. This particular one is what? Public and accessible from other classes, that is UI controllers, activity fragments. So here we are only overriding the get method. Okay, so since only the get method is being overridden here, this particular property is immutable. That means it's read-only. So when an outside class accesses it, it just returns the value of underscore count, and its value cannot be modified. You cannot change it, and this actually helps you to protect the data inside the view model from some changes, any unwanted change like that. Okay, but it actually allows external callers to safely access the value. So with what we have actually just learned, let's now add a backing property to our current scrambled word. Okay, this current scrambled word. Let's get a backend property from for it. Okay, so how do we do that? Well, I already have a private variable here. Okay, this can be modified, so I'll just add a backend property. Okay, by saying val so I'll change this one, the first one, to have an underscore, so kind of. Okay, and then okay, and this is of type string. Okay, so I can just actually just do this here, and okay, you can actually just do this here, or just add one. Okay, so what do you want to get? You want to get the current scrambled word. So this is we adding a backend property. Okay, now in a game fragment, now we're going to now update the method. Let's go back here. So let's update this method, this here that makes use of this current scrambled word. So we will now use our view model to access it. Now we have already created this view model instance. So with this, we can now access the current scrambled word. So I'll now say view model dot current scrambled word. You can see that. Okay. So let's now do something. So I'm going to delete. Let's see. Where is let's look. Okay, so on submit word. So I want to just delete this code. We'll implement it later, or let me just comment it out. We'll implement it later, so we can just run to make sure, let's test the run and make sure that we are actually fine, okay, that everything compiles without what error. So one last thing, just to reiterate, don't ever expose mutable data fields from your view model, okay? Make sure that the data cannot be modified from another class, okay? Because mutable data inside the view model should always be private, please. It should always be private, okay? So take note of that. So, okay, so I don't think we have much issues. So we will actually finish this, view models in the next class, that's for sure. But let me see if I can just do one last thing before we hit the 9 o'clock mark. Okay. So let's see. So okay, this is compile SDK stuff. Okay, so it's not really, and it's not really a big deal. I need to change the minimum compile SDK. So I need to do some very little stuff. So it's not like we have a bug here per se. Okay, let's see. Okay, so let's see if we can actually just talk about the view model lifecycle, the lifecycle of a view model. Okay. I think I know what to do, but not in this class. Okay, so the lifecycle of a view model. Now, this is very, very important. Okay, this is very, 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 very important. So I'm going to actually just share something. I'm going to share this. Let me share this image. So just okay. Just give me a minute. I need to share this for us. Okay. Just. Okay, so. Okay, just a minute, please. Okay. Okay, yeah, so let's look at the life cycle of a view model. So the framework, okay, keeps the view model alive. Okay, the underframe keeps the view model alive as long as the scope of the activity or the fragment is alive. So a view model is not destroyed if its owner is destroyed for a configuration change or like screen rotation. The new instance of the owner reconnects to the existing view model. So you can actually see this here. We have the activity. When your activity is created, the onCreate, onStart, onResume is called. At the same time, your view model is created. So you see the view model lives to the point where even when you rotate, on pause, on stop, on destroy is called, the view model is still alive. When there's a new activity instance created, on create, on start, on resume, it's still alive. Now, finishing your code, when on finished method is called from the code, it is still alive. Okay, it is only cleared when the activity is finished. Okay, that is when it is what's cleared, when the activity is actually what's finished. So let me see. Let's see. Let me show you guys. Let me show you guys. Let's just implement this, so we actually get to see it. So I'm just going to do something here. I'm going to do init. So init is actually initialize. Okay, so let's do a log cat stuff right now. So for the tag, let me say game frag, and then for the message, I'm going to say game frag created. Okay, so the init there is actually is a block that Kotlin provides, the initializer block, okay, or called init block. It's okay. It's a place for like initial setup where you have to maybe set up some code, okay, like an initial setup that is you need during the initialization of an object instance. Like when you want to initialize game view model, there's probably something you want to actually be set up before like in that process of creating the object instance. So you put that in your init block, okay? Okay, so this code, this block of code is actually run when the object instance is first created and initialized, okay? So take note of that. So I'm also going to do something. Let me override. So there's an uncleared method, okay, that I'm going to override. So let me just copy this. Okay, so game frag, let's say destroyed. Hope I'm trying to rush this. Okay, game frag was destroyed. Okay, so what we want to see now, the view model is destroyed when the associated fragment is detached. Remember, fragments are kind of like in activity. So when the fragment is detached, okay, the view model is destroyed. Okay, or when the activity is finished, then the view model is destroyed. So right before the view model is destroyed, the uncleared callback is called. Just before the view model is destroyed, this function is actually what called. Okay, so let me do another thing now. In let me do something in our game fragments. So here, let me do something. I want to, let's add a log statement here in our onCreate view. Let me add a log statement here. So so on created view, so here is where the game fragment is created or probably recreated. Okay, so that, and then one last method I would want to override. Let me just do it here actually. The undetach, okay? The undetach. So here, so when this fragment is detached, you should see a log statement that said the game fragment has been destroyed. Okay. So let's run this, and then I'll open logcat now. So let me bring out my logcat. I think I may have to fix this. Like really, I have to drop down my SDK. Okay, so let's just do this. Okay, so let's see. Okay, sorry, that should be okay. So okay, minimum is 23. Okay, so is it the minimum is specified? Okay. Okay, so okay. Let's just see if that solves the problem. Okay. But I really needed to. I hope this doesn't really take too long. Okay, but I needed to actually show us, this is the life cycle of a view model. Okay, so you get to know when it is, when those stuff actually happen. So let's see if we are fine. I think we are. Okay, so while that's running, okay, so in the next class, okay, we're now going to populate the view model. So we'll actually now work on the data in the next class. Okay, we're going to finish this application in the next class, so don't try not to miss it. We're going to finish it in the next class. Okay, so we'll populate the view model and then the data and everything, and get to see how that actually works. Okay, so we're going to do a lot of logic work tomorrow. We're going to complete the application actually tomorrow. Oh, sorry, the next class rather. Yeah, the next class we're going to complete the application. Okay, so let's bring this back here. Okay, so of course the app is not really working as it should now. So let's actually, so what happens now? So let's actually now do a few things. Let me enable auto rotate here. Okay, auto rotate is enabled. So let me open up my log card. You can use this bin to clear, okay, to actually clear that, okay. And then well, you can actually just do this, or you can leave it at your browser. And I'll just type game frag just to actually help me identify stuff. Okay, so let's rotate this now. Okay. Okay, so let's see. Okay, so rotating, let's see. Hope I get that. Hold on. Where is this young man? Okay. So our log message is not coming out. So let me check. Okay. Uncleared. So let's run this again. So I'm sure I didn't miss out on. Okay. Okay, so I think I gave the wrong message. Okay, so you can see when we actually run the application, the game. So let me clear this. Let me clear this. Okay, and then let me run this again. Okay, so you can see we have when we run the application, the game fragment. So what we are seeing here, game fragment destroyed, game fragment created / recreated. So uncleared is called. And then in the view model, this is the game fragment created is called. Okay, so that means this view model has been initialized. This game view model has been initialized. Then if we check out game fragments, okay, so onCreate view is also called too. Okay. Now, so let's do the rotation. So you can see when we rotate, okay, what is called here is the undetached. The fragment was detached from the activity. Okay, so the undetached is actually what's called. So that's why we actually see this log message. And as it was called, it was also the fragment was recreated again. This fragment is now what recreated. Okay, so let me add it. Just play around with that. Okay, so so that's actually the life cycle, and these are things you need to really understand. Okay, these are things you really need to understand. So let's take this back to how it was. So you see when we change, you can actually see that. Okay, so that's that actually shows you the life cycle of the view model. Okay, so that's basically that for today. Okay, so but if you notice, let me take this back to, so if I exit the application, okay, you can see, of course, undestroyed is called twice. Okay, undestroyed, so the game view model is destroyed. Okay, and then the callback uncleared is actually what's called. So this uncleared is what's called when you exit the application. So at the same, it means that the game fragment also, okay, has been destroyed. Okay, so let me make it clear. So here I could say game. So here should be game frag. Actually, here should be game view model. I think I copied it. So I was using same. Yeah. So the other one should be, so this is for the fragment. So yes, game fragment. Good. So this makes it clear now. So you don't see a lot of game frag, and the likes. Okay, so I'm just gonna clear this. Then I'm gonna open the application. So when I open it, you see the game fragment is created. Okay, and the game view model is created. Okay, so for the game view model, I had this this is the message I'm sending for for the game view model. So you can see that. Okay. I think I should. So just note that. Okay. And then when we rotate, you can see game frag destroyed. Okay. Which yeah, and then we have the game frag created and so that's basically that. Okay, that's basically that. So when we rotated this, you can see that is not from the game. Our tag does not have game view model, so it's still for the fragment that was destroyed and recreated. Okay, but when we exit the application, the view model, okay, is what destroyed, and then the fragment is also destroyed because you have exited the application. Okay, so that's actually that, guys. Okay, so in our next class, we're going to be finishing this up. We're going to be finishing up the application. Okay, we're going to finish up the application in the next class. So thank you guys very much. Okay, if you have any questions, please reach out to me on Slack. Thank you guys. Have a wonderful night.
Okay, so good evening. Yeah, so let's get started. So in the last class, we talked about, we introduced view models basically, and then we were able to look into some concepts, and then of course we rounded up by talking about the view model lifecycle, understanding the view model lifecycle. Okay, so we said that the Android framework, okay, keeps the view model alive as long as the scope of the UI controller, that's the activity of the fragment, is alive. So the view model is not destroyed if the owner is destroyed. But when you have a configuration change, that's like a screen rotation. Okay, so the new instance that we created, okay, we connect to the existing view model instance. Okay, so we talked about that in the last class. So let's just head into implementing some of the methods we have here that was in the game fragment. So let's actually, do some stuff now. So let's write some code. Now, first things first, let's populate our view model. Remember, I want to drive the data from the view model. Okay, I want to drive UI rather from the view model. So what we want to do now, let's just populate our view model. So first things first, we're going to write a code to get the next word. Okay, we're going to write a code to get the next word. Yeah, and then we'll write a code to validate the player's word. Okay, so check if the word that the person has scrambled, okay, if it's actually the right word, and then if it is, we'll increase the score. And then of course, we'll still write create method, helper method also to check the word count, because we want there has to be a particular count of less of 10. So I don't go more than 10 words, else the game will just keep on going and going. So that's what we are going to actually kick off with now. So let's start. So I'm going to create so first of all, let me create a variable. So I'm going to make it a private var. So I'm going to call this words, words list, as list of words. And this is going to be of type mutable list. Remember, we talked about lists and mutable lists. So this is a mutable list, and this mutable list is going to be of type string. Okay. So we'll just create an instance. So we're just creating an empty list. So now the words list is just an empty list that holds string values. Okay, it's just going to hold. So basically, in this context, it's going to hold a list of words that we're going to use in the game to avoid repetitions. Okay, so that we don't have one word appearing more than once. Okay, then the next thing is I'm going to create a let init variable. Now, I think I've said this before, but let me just reiterate again. So, typically when you declare a variable, you have to provide an initial value. Okay, we talked about variable declaration and variable initialization. So declaring a variable, okay, it's just like getting a container. Okay, but you have to put something inside. So when you declare a variable, you have to give it an initial value. But in a case where you're not ready to give it a value yet, you could actually give it a value later, that you could initialize it later. Okay, so that means it's going to be a late initialization. So that's why we have the keyword late init. Okay, so the interesting thing about late init variable is that, of course, when you create a variable, you're actually creating a space in memory. Okay, so but for late init variables, the memory is not allocated to the variable until you have initialized it. Okay, until you have initialized it. So just think of it like you getting a bucket of water, a bucket to store water. Okay, and then you don't put that bucket in a particular place except you put water inside. So that's basically what we're trying to say. So memory is not located to the variable until it is initialized. That's when you're making use of the late init keyword. So we're going to make use of it. So I'm going to create a late init variable. So private late init var. Okay, and then I'll call this current word. So for now, the current word is not going to have a value, but it will have a value later, because we're going to use the current word is just the word that you're going to that's actually being what's displayed. So it's going to hold the word that the player is trying to unscramble. Okay, that's going to be the current word. So we're not initializing it now, but we'll initialize it later. So let's now create a helper function. So I'm going to say private fun. So let's create a function to get the next word. Okay, create a function to get the next word. So the next word, so how can we get the next word that will be displayed? Okay, so of course the next word is still the current word. Okay, the next word is actually the current word now, right? So I've created a late init variable already, so I'm going to initialize it in this method. So the next word is going to be a random word from our list of words. So remember, we have an all word list where we have a list of words. So I'm going to randomize it. Okay, so let me just open this up. So this is an all words list. So it's just a list of words that we're going to be making use of for the game. Okay, let me just show you that again. Okay, so that's that. And then, so that's actually how we're going to get, so we've gotten the next word now. So, but we need to convert the current word string to an array of characters and then assign it to a new value called temporary word. Now, basically, because to scramble the word, okay, we need to shuffle the characters. You understand? So you have a word, let's say you have a word company, okay? So to scramble it, we need to convert it to an array of characters. Like, you understand, just simple, remember a string is just a sequence of characters. Characters A, B, C, D, those are characters, okay? So when you have a sequence of it, that gives you a string, okay? So, but now we want to convert this current word, because our current word is a string, okay? If I hover on this, you can see it is a string. So I want to convert it to a character array, that is an array of characters, so we can actually, scramble it. So I'm going to first of all create a variable. So let me make this a val, because it's not going to change. So I'm going to call it temp word. So the word temp for temporary. Okay. So it's going to be current word. Okay. Dot. We have a method called toChar_array. That's the character array. Okay. So with that, I can now do temp word dot shuffle. So this will shuffle the characters. So company, to shuffle the word company. That's basically what that actually does. Okay. So just note, an array is actually similar to a list. We'll talk about arrays actually. So an array is similar to lists, okay, but it has a fixed size when it is initialized. Okay, an array is actually similar to a list, but it actually has a fixed size when it is initialized. So it cannot actually, like, you can't expand an array or even shrink it. You can't increase it or decrease it. Okay, you need to copy an array before you can resize it. You need to actually create a copy of it. But for list, you can actually, this has the add method, you can .add, you can even .remove. It has those functions to do that, so you can increase and decrease that. But arrays has fixed size when it is initialized. So sometimes the concept of what we're trying to do, sometimes the shuffled order of the characters sometimes can actually be the same as the original word. So imagine you have a word, let's see, what 4-letter word can we use? F-O-U-R, let's say 4, the letter 4, F-O-U-R. Now, it's possible that it's shuffled and you still have F-O-U-R. Okay, it's possible. So we need to actually check to make sure that that doesn't happen, because if you shuffle it and it gives you back the original word, then that's like a actually just giving the person bonus or a free score. So we're going to add a while loop. Okay, remember I talked about loops. So we're going to add a while loop around this shuffle, where we're actually shuffling this word. We're going to add a while loop, because what we want to do basically, we want to continue the loop until the scrambled word is not the same as the original word. So how do we do that? Let me just going to cut this. So I'm going to say, now, while our temporary word, so now remember our temp word now is a character array. So I want to convert it to a string. So to get the actual word, okay? So while that dot to string, convert it to string, and then we can use, there's a function here, equal, dot equal. So we want to compare. So it passes it. So what do we want to compare it against? We want to compare it against the current word. Okay, and then we want to, so the second parameter is to ignore the case. That's, we should ignore if it is capital letter or small letter. So I'm going to say false. So we can ignore the case. So that's basically what it is. So while this character array, when you convert it to a string, okay, while it is, so yeah, dot equal. So this is going to return, this is going to give you, yeah, okay, so this is the, yeah. So while this is true, so shuffle it. Yes, so that is basically that. So what we're saying is, look, when you, here we're actually shuffling, we've converted it to a character array. Now, when it's converted to a character array, we'll now say, okay, fine. While this temporary word, we're converting it back to a string. If it is equal to the current word, okay, shuffle it. So shuffle it till they are not the same. That's basically what we want. That's basically what we're trying to achieve. So we don't have to give the same word for someone to scramble, like you're giving the person an answer or something like that. Okay. And so the next thing is, let's add an if else statement here now, because we want to check if a word has been used already. Okay, we want to check if a word has actually been used already. So if the word lists, our list of words, has the current word, if it contains the current word, then we're going to, let's call get next word, because we do not want to display, you know, a word that has actually been used before. Okay, we don't want to display a word that's actually been used before. So that's why we have this word list, this list of words here, because it's going to hold the words that we have actually used, so we can make use of that. So let's move. So let's do this. So I'm going to say if our word list, okay, dot contains, sorry, sorry about that. Okay. Okay, sorry, let me get that quickly. Okay, sorry about that. I think okay, thank you. I'll get this back. Okay, yeah, so I trust you can see my screen. So if it contains the current word, Okay, that's basically what we actually want to do. So if it contains the current word, okay, then we'll get the next word. We'll call the get next word method. Okay, so we are calling back this method because we don't want to display a word that's actually else, of course, the user would actually remember, oh, I've actually done this before. So, why not? I can actually just get it again. So that's basically that. But if it does not, so if this is true, then it will get the next word. Now, but what if it doesn't? So if it doesn't, now we're going to update the value of our unscrambled word, our current scrambled word rather, with the new scrambled word. And then we'll increase the word count and then add the new word to the words list, because we need to add the new word to words list so that we get to know the words that we have actually used. So let's do that. So let's update the scrambled words. So I'm going to say else okay, our current scrambled word. Now, our current scrambled word, okay, is the string. So let's do that. So what will be our current scrambled word? So it's going to be the temp word. So I'm going to now remember our temp word is actually a character array. Okay, so I'm just going to, so I can actually just do this, or I could just, do this, and then I'll pass in temp word. Okay, so could do either of this. Okay, and then yeah, so of course, so if it's not the if word list does if it contains the current word, get the next word, else we'll get we're going to get the current scrambled word, then we'll increase the word count. Okay, so our current word count will now increase. Yep, yes, so yeah, so plus, so that will just increase it by 1, and then we can now add the current word to the word list. So word list dot add, then I'm going to add the current word there. Okay, so that's basically that. So that's how we actually get the next word. Okay, that's how we get the next word. So let me just run through it again. So first of all, we created we have a current word variable. Okay, so it's a late init to get the current word that will be displayed to the user, the person who is playing the game, and then we're getting a random word to store in that variable. Okay, so the current word is the word that's being displayed, and then we'll get a temporary word. We created a temporary word variable, okay, that will hold the character array, that is the current word, but now it's no longer a string, it's just a list of characters, an array of characters rather. And then we are checking that, look, if this temporary word, okay, if it is equal to the current word, of course, we have to convert it to a string first to check that equality, because the current word is actually a string. So if it is the same, shuffle it. So to make sure that we do not have the same word coming out, okay? Because of course, when you're just shuffling, it's possible that you can shuffle, like I told you, we have 4-letter word. It's possible, even 3-letter word, it's ATE. It's possible that when you shuffle it, ATE still comes out. So that's actually that. So we should have something like CAE and stuff like that. So that's just me, giving some examples. So while the temporary word, okay, when you convert it to a string, while it is equal to the current word, then do what? Just shuffle it. But then we now need to check if our word list contains the current word. Okay, if our word list contains the current word, if it does, get the next word, because we are done with one word already. We shouldn't repeat it anymore. Okay, we shouldn't repeat it anymore. So we get the next word. But if it doesn't, then our current scrambled word will now become our temporary word. Okay, that will increase the word count. Okay, we'll increase the word count and then add that current word to the word list. So our word list is just an array of what a list of strings rather. So we can always use it to compare. Okay, so that's okay. So yeah, let me switch to my other screen. Yes, sorry about that. Okay, so okay, I think yeah, good, super.
I'm not seeing anything, sir.
Yes, I'm coming. Yeah, confirm you can see it now. Should be able to.
Yes, I can see it. I can see it.
Okay, okay, good. Okay, so that's actually that. Now let's do something. Now I've created the get next word method, which is going to get the next word and display to the user. Okay, it's going to get the next scrambled word. So we're actually going to call it when the game view model is initialized for the first time. Okay, we're going to make a call to this get next word method when the game view model is initialized the first time. So we're going to use the init block that we actually had where we actually were talking about the view model lifecycle. So we'll use this to initialize our late init properties. So let's use this to initialize our late init properties in our class. And one of the late init properties we have is the current word. Okay, so the result of this will be that the first word displayed on the screen will be a scrambled word instead of text or something or what else. So we have where is that guy? So game fragments. Let me just open this up. Okay. Yeah. So yes. So this is what we are actually looking for. So instead of having, basically what we want is that when we run this the first time, let's assume the first word is test. We don't want to have test. Okay, let me show you something. I'm going to run. Well, let me run this now. Let me just run this application. Let's test this out. I want to show you something. I will show you something quickly. Let's run this. Because if you check here in line 14, we said the current scrambled word and we gave it a value of test. Okay, so when we run this application, for the very first time, our current scrambled word will be test. It will always be test. Okay, because we have not actually ran this. We have not called this get next word method. So because it's when you call this method, then our temporary word updates this current scrambled word. But here, so that's why we want to call the get next word method in the init block, so that when the game view model is actually initialized for the first time, okay, we're actually going to have a scrambled word instead of this test variable. So you can see we have test, okay, because that's the current scrambled word. So I'm just going to now call, so let's call the get next word method here. Okay, so let's call it here. Now, but before I run this, let me add the late, let's do this, okay? Okay, let me make this, let's make this a late init. Yeah. So I'll now take out this. Okay, and this would work because we're going to initialize it. Okay, so this is a promise, the late init variable. We're promising that we will initialize it, of which we will, okay, of which we will. So let's run this now and then let's see. Let's see what we have. Okay, so okay, let's let me run this again. So we have this. Okay, get next word. Okay. Okay. Okay, so let me show. Yeah, exactly. So let me show you what happens. So you see the app is crashing. Now, when you check your log cards. Okay. Now, of course, your log card actually helps you to know. So let's see. We have an attempt to invoke this on a null object reference. So let's see. Okay, we says we're attempting to invoke interface method, which is the dot contains, yes, on a null object what reference. So, and then that points us to the whole of this. Okay, so this is the current word, which is a string. Now, it's possible, okay, it is very, very possible that our current word is actually null. Okay, so what I'm actually going to do to solve that is that I'm going to make this word list variable nullable. Okay, I'm going to make it nullable, okay, meaning that it can actually take a null value just to solve that problem. And then, so here, I'm going to replace with a null check here. But here, I'll have to now, so even if I replace, I need to check, okay, I need to check because now my Boolean is no longer, is now having a, you look at the question mark here, it means that it's nullable. So it required Boolean, but it's seeing a nullable stuff. So I'm just going to have to add this other condition. So if the word list or contains character, if it's actually true, we'll get the next word. Okay. But if it is nullable, if there's a null value, then nothing will actually happen. So that stops it from that actually stops that. So let's see. So I'll run that. Okay, so we have a null value now. Okay, we have a random word, okay, that's actually being displayed. Okay, so yeah, so sometimes you really need to think very well, okay, whenever you have errors. Okay, so the next thing we're going to do is to add another method that will help process, like modify the data inside the view model. Okay, so methods like a next word from method. So let's say a function, this is more like a helper method on next word. Okay, and I would want this to return a Boolean. Okay, so basically what we want to do here is to get the next word from the list and then return true if the word count is less than the maximum number of words. Okay, so we shouldn't exceed 10. So what I'm going to just do here, I'll say, so we'll return if our current word count, okay, which for now is 0, okay, is less than the maximum number of words. So our maximum number of words, we have declared that already to be 10. Okay, here in this our list of words class. So we're saying if the current word count is less than the maximum number of words, then get the next word. Okay, and then we'll return what? True. Else, so let me just make this. So return false. Okay, so return if the current word count, okay, if it's less than the maximum number of words, get the next word. Okay, and then we're returning true. So else will return what? False. So if this works, we're now returning what? True. But if it's not, then that means false will be the return value of this next word function. So this is a helper. This is a helper function that we're actually going to make use of. So that's actually that. So we're going to use it, but not now. So, but I want to, let's see, because of time, I want to introduce you to dialogues. Okay, I want to introduce you to dialogues, because if remember when we did a demo of the application, the game was not ending. It was just, you know, moving on and moving on and moving on, even after 10 words. Okay. So now we're going to modify the application so that after the user goes through 10 words, then the game is over. And then we'll show a dialogue with the final score and give the user an option to play a game or exit. Okay. So of course, this is the first time we're actually looking into dialogue. So a dialogue is basically a small window, small screen that prompts the user to make a decision or probably enter information, additional information. Okay. And of course, it doesn't usually fill the entire screen normally. It doesn't usually fill the entire screen. Okay. And it just requires the user to take an action before they can proceed. You understand? So that's basically what a dialogue is. Okay. Maybe when you try to sign up and then there's this, what you call a prompt, you may call a prompt that comes up. Okay. Sign up successful. Click here to continue. That's a dialogue. Okay. So Android actually has, you know, gives us different types of dialogue, but for this class, we'll just learn about alert dialogues. Okay. We'll learn about alert dialogues. So let me just actually just show you this image. Okay. So you can see, so this is the alert dialog. These are alerts dialog. Okay. Now the reset settings. Okay, that's the word title. It's optional. You must not put a title. Okay. Then this will reset your device to its default factory setting. This is the message. And then the one labeled 4 is the text buttons. Okay. 5, of course, is just the actual screen. Okay. So this is drawn on a particular word screen. Okay. So this is basically the anatomy of an alert dialog. Okay. So just to take note of that. So let's implement it. So we're going to use the material alert dialog from our material design components library. Okay. So, but before that, since we're going to make use of the score, let's add a backend property to the score. We talked about backend properties. So I'm going to make this, let's say an _0, and then I'm going to say val score, which is of type int. Okay. Then I'm going to say get score. Yeah, so just adding a backend property to that. Okay. So now, so in our game fragment, that's where we're going to add a function to do that. So I'm going to go to my game fragments now. Let me just do that here. So let's add a function to create and show alert dialog. Okay, so let's do that. So let's dive in. Private fun show dialog. So let's call it show dialog. Okay, so let's start. So remember I said we're using the material alert dialog. Okay, this is from the material design components library, okay, of Android. Okay, because it actually follows material guidelines. So let's do that. So since our dialog is a UI, okay, it's UI related. Okay, so that's why the game fragment is going to be responsible for creating and showing the final score dialog. Okay, because it is UI related. So we're not going to put it in the game view model. Okay, so yeah, let's do that. So let's call the material. So I have what the material alert dialog what builder. Okay, could I just click out? So I'm going to click this. So you can see it takes 2 parameters. Okay, there are 2 listen. So there are 2 constructors here. One takes the context, the other one takes context and then overrides a theme resource ID. Okay. So, but for now, we're going to just use the first one for context, and I'm going to say require context. Okay, so I know I've used this before. I've actually used context and everything. I've said it before. So, but let me just see if I can talk about it a bit. Now, The context, just as the name suggests, okay, it actually means the context or the current state of the application. Okay, so it refers to the current state of the application or the activity or the fragment. Now, the context here, since it refers to the current state, it contains information regarding the activity, regarding the fragment, or regarding the application. So usually, it's actually used to get access to resources, databases, or some other system services. Okay, that's basically what this context is all about. Okay, so that's actually that. So we're going to require the context here because we're not, if we're using an activity, we can actually easily say this, okay, because the context is related to the more to the activity, okay, but in a fragment you can require the context. So it's going to just get the activities context. So I'm going to require context, okay, and then so once we have gotten the context, I'll just click enter and just say dot. So with that, I have access because I'm calling the material alert dialog builder. I have access to some of its properties methods. So one of them is to set the title. Okay, so let's see, did I create something? Let's see. So in case you actually created a string resource, okay, you can actually just get it by doing calling get string and then say r.string dot, let's say, congratulations. So I already have that. Okay, then the next thing is to we'll set the message. So I'm just going to come out here, click enter and say dot set message. So I already have something, I think. So I'm going to say get string and r.string dot you scored, that is, you scored something. Now what did you score? Now I'm going to say view model dots. I'm now going to get my score variable. Okay, I can get it now. Okay, that's why we talked about the backing property. Now I'm going to explain this here. Okay, so basically if you look at this, you scored, you see this is what I have here, you scored, and then I have this %d here. So this is more like a placeholder. Okay, a placeholder. So because I have this here, I can now place a variable, a value on this. So you scored, let's say 5, you scored 6, you scored 10 and stuff like that. So that's basically that. Then the next thing, so we need to make our alert dialog not cancelable when we press a back key. So we don't want to press the back button or back. We don't want the dialog to go out. Okay, so I have set cancelable method and I'll pass in false. Okay, so you can't cancel it by clicking back because we need you to either to click on one of the actions. Then let's add 2 text buttons. Okay, the first one is going to be exit. The next one is going to be play again. Okay, so we're going to do that using 2 methods. We have a set negative button method and we have a set positive button method. Okay, on our alert dialog. Okay, so this is what I'm going to do. So I'm going to say dot set negative button. Now for the set negative button, you have to put in the text. Of course, what do you want the text to be? So get string, I have r.string dot. So since it's a negative one, is exit, that is to exit the application. Now, so to set the negative button, now this is actually, it requires a lambda. So then we'll talk, let's just say, so I'm just going to call, so I'll call exit game here. So if you actually choose the negative button, then we'll call a method we have called exit game. So this will just close that activity. This will finish the activity. So but let me just do this. Okay, so because it's not where we'll talk more about listeners and the like. So you'll get to talk more about the interface. So that's for the negative button. Okay, so then the next one, I'm going to set the positive button. So just click on enter dot set positive button. Okay, give it the text that should be displayed. So R, so the positive button is the good guy. So it's going to say play game. So I have a string resource already. Okay, so if I just hover, you see I have it here already. That's why I'm getting that. So play again. And then I'll open up my curly brace. So I'm just going to add an underscore. And then like this. Then I'll call restart game because we want to play again. So we have our restart game here. So our restart game is going to just call the update next word on screen. Okay, which displays the new scrambled word. Okay, so let me see if I can talk a bit. Well, I know you may be seeing this, and of course it's new to you. Okay, but this is just a it's actually just a shorthand though. The shorthand of actually writing something like this. Okay, the shorthand of writing something like this. Okay, but basically here, which basically what this actually means, if we're doing something like this, we are basically saying the set negative button, okay, takes in 2 parameters. That's what it actually means. If we're doing it this way, okay, it means that the set negative button takes 2 parameters, because if we're doing it this way, this is what we'll have. I have to close this out. Okay, this is basically what we would have had. Okay, right? Okay, no, just yeah, this is basically what we would have had. Because yes, in the actual sense, it takes 2 parameters. It takes a string, okay? In the actual sense, the set negative button, it takes a string. You can see character sequence, which is a text, which is what it takes. This is one of the parameters. And then it takes a function. Now that function is the dialog interface dot on click listener. So there, you can see params here. That's parameters that it takes text. The text to display in the negative button, and then a listener, which is a function, the dialog interface dot on click listener that is going to use so to respond to a user's click. Okay, so this also can be represented as a lambda. Okay, so when the last argument being passed in is a function, you could actually just place lambda expression outside of the parentheses. So, but we actually call this is actually called trailing lambda syntax. So this actually works. It actually works. Okay, this is not a red line something, but you can see when the suggestion that I'm being given here is like move lambda argument out of the parentheses. Okay, so move this lambda argument here, move this guy out of these parentheses, out of this. So that's what basically that. So when I do that, this is what we now have. Okay, so it's called a trailing lambda syntax. We'll get to use more of this actually with time. Then, well, lastly, we need to now call the show method. Okay, so this will actually show the dialog. Okay, that's particular command. So you must actually call it. Okay, so let's now implement on click listener for the button. Okay, this submit button. Remember, it's not working. So let's implement that. So we're going to use the view model and the alert dialog to implement the game logic now for this submit button. Okay, because you know the submit button needs to check if you've gotten to the end of the number of words, then that dialog should actually pop up. Okay, so let's do that. So we're going to display the scrambled words. Okay, so let's do something now. So let's go to game view model. So let's do something. So okay. Okay, so let's do this. We already have, so yeah, we have 1, So yeah, so this is the submit word. So this is the code we had before. So I'm just going to close this. So to submit the word, I'm going to say if our next word, okay, so our next word is actually in the view model. So I'm getting that the logic is there. So if this is true, okay, so if view model dot next word, okay, this gives a true or false. So if this is true, that means if there's a next word, okay, what do we want to do? We want to call the update next word on screen. And what this update next word on screen method does is that it takes, binding.text view. So it just gets the scrambled word and displays it on the text elements we have. Okay. So if that is true, update it, else sorry about that, else show the dialog. Okay. So that means if there's no next word, okay, then show the dialog. So let's try that. Let's run this and then let's see. So we may have to actually really play through some words. I just hope I'm able to get all the words actually. Okay, so well, okay. Let me fail. Okay, so our word count is not okay. So you can see it's actually of course it's actually counting, but we are not updating it here. So we're going to do that later. So you can see, congratulations. Okay, you scored 0. Oh wow, I'm sorry about that. And then you can see the two buttons, play again and exit. So play again. Remember for the play again, we actually said the play again calls the restart game. And what does the restart game method do? Have I passed it? Yes. So it sets error text field to be true and then updates. It calls the update next word. So when I say play again, it calls the update next word. So you have a new word here. So I'm just going to be pressing submit, play again. You can see. Okay. So exit will close the game, close the activity. So that's basically that. So that actually works. Okay, that actually works. That actually works. So we're able to show the dialogue. Okay, so let's actually, so let's implement. Well, not okay. We'll implement the skip button. So we need to validate a player's word, because if you check here, I'm just typing anything. Okay, so it's not really validating it. It's not even checking. Okay, so let's see if we can quickly do that. Okay, so I'm going to create a method, a helper method to validate a player's word. Okay, now here, so that method, I'm going to call it increase score. Okay, because if the word is the right one, of course we should increase the score, right? Okay, so here, basically what I'm just going to do, so I'm going to call my underscore, the score value, then of course, increase it by, so we have a value we created, the score increase value that we created in our list of words class, okay? A const val, you can pick it up from anywhere. So it's 20, so increase it by 20, increase the score by 20. Now that's one. Second thing, we need to check if the user word is correct. We need to check if the word is correct. So function to do that is user word correct. So of course we will pass in a parameter here, because we need to check when you say is the user word correct, which word. So let's pass in a parameter, a word that's going to check, run that check with. Okay, so a player word of type string, and then this should return a boolean. Okay, because if it is correct or not, true or false, is it correct or not? So how am I going to do this? I'm going to say if player word, okay, which is whatever we're going to pass into the is user word correct, to check if the word is correct. So if that dot equals, if it's equal to the current word, Okay. So we want to check if that. So I'm going to pass, so we want to ignore case. We want to check for capital letter or not. So if that is true, increase the score. Okay. And then return true. Okay, because this is a return statement here. So return true. Else just return, or well, you must not put an else, you can just say return false. Because if this statement doesn't run, then it will return false. Okay. So this rechecking if the user word is what correct. And then quickly, what else can we do? So let's update our text field. Let's update this our text field, right? Okay. Or so here, let's update this. Now, let's show how can we show errors in a text field. Okay, this text field, how can we show errors here? Now, for material text fields, okay, we're actually using we're actually using a text input layout, okay? This is the layout, and then it has the text input edit text. So this comes with a built-in functionality to display error messages, okay? It displays error messages, comes with that functionality. So you can actually show an error in the text field, okay? So let's do that. So I'm just going to so we have, let's see. Okay, so we already have this here. Okay, so here you can check. We're saying if there's an error, okay, we have binding.text field. So the text field here is our our text input layout. If I do a Control B after highlighting, it takes me to where that is declared. So if this guy, so we are checking if it is setting the error enabled to be true. The error enabled what value, okay? So this checks. So you can see this property, okay, checks whether the error functionality is enabled or not. So we want to enable the error functionality, and then the error we are giving here is what try again. So if there's an error, enable the error and then try again. Else, disable the error and then let there be nothing on that text field. Okay, set it back to empty. Okay, set it back to empty. So we basically just need to call this method with true or false as the parameter. That's basically what we just need to do. We just need to pass in a true or false for it. That's all. So we have implemented submit word. Okay. Yes, we have implemented submit word. So when a word is submitted, okay, let's validate the user's guess by checking against the original word. Okay, let's validate. Okay, let's not just call up show the word and then show dialog. Let's do some validation when you submit the word. So we want to validate the user's guess by checking against the original word. So if the word is correct, then we'll go to the next word, or we'll show the dialog, that's if the game has ended. But if it is not correct, then we'll show an error, okay, on that text field and stay on that current word. So how do we do that? I'm just going to create a variable for our player word. It's going to be binding. So I'm going to say bind.the text input edit text. So this is the edit text. This is different from the layout. So this is the layout that houses the field, the edit text field. So we just basically want to get the text or the user's guess. So we'll convert this to a string. Okay. Now let's validate the player's word. Okay, let's validate the player's word. So we need to check if the player's word is using this. So this is what I'm just going to do. So if, okay, our view model, so once you get that is user word correct. You remember we did a logic to check if the user word is what correct. Sorry. Okay, and this what checks, it takes in a string and checks if it's equal to the current word. If it is equal, it increases the score, else it just returns false. So we want to now check if the user word is correct. So since this is user word correct takes a string, we now want to pass in the player word. So whatever the player types in or guesses, then we'll check if that is correct. Okay, so if it is correct, okay, then our set error text field will pass in false. So do not enable it. Okay, and stay on that correct word. Okay, but let's move this. Let's do something. I want to do I want to do a nested if now. Okay, I want to do a nested if. So I'm going to move this. Let's see where this guy ends. And then this, okay, so I'm going to move this guys here. Okay, I'm moving it into this place. So if the word is correct, set the error text field to be false. Okay, now if this the next word, if this is true, okay, then update the next word on the screen. Okay, else just show the dialog. So this is Windows doing a check. So I just move that into that. Okay, and then we'll now have a final else. That's if the word is not correct. Okay, this is where our this particular if statement starts from. This is where it ends. So here I'm just going to say else. That means the user word is not correct. We'll set the error text field to true. Okay, set it to true. So let's see. Okay, let's play this now. Let's play this. So you get to see how that actually works. Okay. Really hope we can finish this up, but let's see. Okay, so let's look at this. What could this be? What word could this be? Well, let me just type anything. And then when I click on submit, you see, it actually checks and sees that this is wrong, and then it stays here. Okay, so we have not implemented skip. So can you help me guess the word? I would love to actually see how the error this thing goes out. What could this be? This is interesting. I'm not really good with word puzzles. Okay, so let me cheat a bit. Let's run it again and see. Hopefully I get a word that's easier. Wow. Puzzle. I think this is puzzle. PU, right? Sorry. Yeah, I think this is puzzle. So yes, this is puzzle. So since this is correct, it checks if the word is correct. So when I submit this, you can see it's correct. So it moves on. This seems like joke. Oh wow. And this is whatever it is. Okay. So the error text field. The error text field. So that's actually how you actually do that. So let's quickly, I think I'll just quickly do this. Okay, I think I'll finish, but I'll be very fast. So let's implement the skip button. Okay, so of course, in case I'm not sure of the word, I can just skip the word. Okay, so it's just similar to the submitting on submit word. So okay, let me just, so I'm gonna say if, okay, so if our next word, okay, if this is true, so set the error text field to be false. And after that, update next word on screen. So give a new word, okay, because we have skipped it. Give a new word. Else show dialog. Okay, so remember what our next word function does. It returns. So this next word is just basically checking is it true or false statement. So what is it saying? what does it do? Is first of all, it checks the word count. If it is less than the maximum number of words, then to get the next word for us, of which this is the function that gets the next word, which we actually worked on the last time. Okay, so that's actually how you do that. So let's run and test that quickly. Let's run and test that quickly. Okay, so let's say I don't know what this is. I do know what this is. This should be classic. Really? Yeah. Let's assume I don't know what this is. So I'm going to click on skip, and then you see it skips that. So till it checks the counts. So when it gets to that, and then you can see our score is 20. And then, of course, I have the option of playing again. Okay, so that's actually that. That's actually that. So yeah, we're going to, so a lot of things, a few things we still need to do. We need to update. These texts are not being updated. The score is not being updated here. So we're actually going to do that. We're going to do that. Okay, so let's do something. So let's verify. Let's see. So we need to be sure that our view model is actually preserving the data. Okay. Let me just do one more thing. So let's update the game restart logic. Okay, because when you run the app, play the game throughout the words in the congratulations. Okay, I don't know if you noticed that when you click on play game, the app won't let you like play game. So let me show you something. Let's see. So you notice it's not actually allowing, when I click on play game, okay, it's not allowing me to actually play the game. And the reason is because the word count has reached the value of maximum number of words. Okay, so we need to reset the word count to 0 when the when the game has ended. We need to reset it to what? 0. Okay, so to do that, okay, we're going to add a method in our game view model. Okay, the function basically is just going to reinitialize the data. Okay, so our score value goes back to 0. Okay, our current word count goes back to 0. Now we'll clear our word list. Okay, and then, sorry, this is word counts. Do I not? Okay, sorry. I thought I actually did a backing this for this. Okay, maybe I'll do that later. Okay, but that's that, and then okay, and then we'll call the get next word. Okay, so this reinitialize data. Okay, good. So this way I'm going to actually call this in our fragment. Okay, I'm going to call it in our fragment. So just let me do that here. Okay, let me do that here. So I'm going to create a function called restart. Okay. Yeah. Okay, so I think I do actually. So yeah, I've actually created something here. So for restarting the game, we set the error text field, update next word on screen. So, but before that, when you want to restart, so I'm just going to call my viewmodel dot get reinitialize data. So let it set everything back to what it should be. Okay. Okay, so let's see. So that's basically that. Let's run this. So now I know the word, it doesn't update. So I'm going to leave that for a later time, or you could try it out. Okay. You can try it out yourself. Okay, so let me just skip to the end. So when I click on play again, okay, I can still play again. Okay, and then so that's fine. So now this doesn't update now, but the value is actually stored in the view model. Okay, but this doesn't really update. So we're going to do that in the next class. Okay, but summarily, okay, we've talked about the Android app architecture. Okay, its guidelines, which says that which recommends that you should separate classes that have different responsibilities and then drive the UI from a model. Okay, and then we talked about UI controllers. Okay, how UI controllers should only contain logic that handles UI and system interactions. But they should not be the source of data that should be displayed in the UI. Put that data in a view model, that data and logic. Okay, and then we were able to talk about the view model class, how it stores and manages your UI related data. Okay, so it allows data to survive configuration changes. And an example of a configuration change, of course, is screen rotation. Okay, so in the next class we get to clean up what we have actually done. Okay, I'll push it to GitHub. I'll push it to GitHub. Okay, so thank you very much, guys. Thank you very much. So we're going to meet in our next class, and then so let me just give you, in our next class, basically we're going to talk about live data. Okay, so in our next class we'll talk about live data in our next class. Yes, live data, and we're going to still make use of this application we have built to set up live data. We're also going to talk about data binding. Yes, we're going to talk about data binding. Of course, I've introduced view binding already, but data binding is a much more interesting way to actually bind your data. Okay, so we're going to talk about that also in our next class. So it's going to be an interesting one, and I'm sure we're going to finish up as soon as possible so we can actually talk about the shared view model. Yes, we can. It's possible that 3 classes actually make use of one view model. So we're going to actually look into that to build a different application, and then we'll talk about navigation and then the back stack. So there's a lot we're going to cover, and then I hope we can actually do justice to that next week. Okay, so thank you very much, and do have a wonderful night.
Thank you, sir.